Okay, we've been using the law of sines so far to solve oblique triangles, and the cases we can use the law of sine for would be the angle side angle, angle side, or side side angle. So now we're going to consider given other three pieces of information, and here are some cases shown below. First one is side angle side. You're given two sides and the included angle. Side, 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 you're given all three sides. And angle, angle, having all three angles of a triangle. First off, this last case, the angle, angle, does not actually determine a specific triangle, because you could form a similar triangle which would have a different size but be the same shape. So here you can see the angles are the same, but I've got two different size triangles. So I can actually solve those. These other two cases, side angle side and side side side, I cannot use the law of sines on because I don't know a side and an angle opposite that side. So I need another method to solve these. That's why we need to create another method of solving other than just the law of sines. So to get there, I'm going to place a triangle in a rectangular coordinate system. There's triangle A, B, C, with little a, little b, and little c, and I'm going to call angle C gamma. This point up here at the top is going to have some ordered pair. Right now I'm going to call it xy. I'm going to use a little trigonometry to determine what the coordinate, the ordered pair for the coordinates of x and y would be. So I'm going to drop an altitude down from ordered pair xy down to b. I'm going to use the triangle on the left here and write some trig ratios for that. So here's angle gamma. The distance from the origin out to this point on the altitude would be your x-coordinate. The distance from this point up to the ordered pair xy would be your y-coordinate. So again, using that triangle, I could say the cosine of gamma would equal the adjacent, which is x, over the hypotenuse, which was a. Multiplying both sides of that equation by a, I get x is equal to a cosine of gamma. Looking at y now, I'd use the sine ratio and say the sine of gamma is equal to y over a. Again, solving for y, I would get y is equal to a sine of gamma. And I'm going to replace then x and y with a cosine of gamma, a sine of gamma. Now, what I'm going to do is actually use the distance formula to find the length of segment C here. So from this point up here down to this point down here. Remember, our distance formula is the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. So when I fill those in, I end up with C, the distance I'm looking for, is equal to the square root of x sub 1, which is b, minus x sub 2, which is a cosine of gamma, quantity squared, plus 0, which is your y for your second your point right here, minus a sine of gamma, which is your y coordinate up here. I'm going to square both sides of this equation to get rid of the radical. I'm going to square out the two binomials in here. And when I do, I end up with c squared is equal to b squared minus 2ab cosine of gamma plus a squared cosine of gamma plus a squared sine of gamma. Now you notice in these last two terms there's an a squared in there. So what I'm going to do is factor out that a squared, which gives me this equation. Noticing at the end, I've got sine squared plus cosine squared, and we know from our Pythagorean identities that that can be replaced with 1. Now just rearranging this a little bit, I'm going to move the a squared up in front of the b squared, and I end up with c squared is equal to a squared plus b squared minus 2ab cosine of gamma, and this is actually the formula that we're going to be using. Not as nice as the law of sines, but this is the formula for our law of cosines. Actually, this is one of three that we could use. Depending on which sides and which angles you're looking at, here are the other two. Now, it's not important for you to memorize those formulas. Rather, it's a little easier if you remember in terms of the wording of how this equation is set up. On this side, whether it be A, B, or C, you're going to have a side squared. That is going to equal then the sum of the squares of the other two sides minus twice the product of those two sides times the cosine of the angle that lies between those two sides. So if I have angle or segment A and segment B here, the angle that's over to the right by the cosine is going to be C, or gamma. Quick review. When to use law of sines and law of cosines? If you're given the case of angle side angle, angle angle side, or side side angle, you're going to use the law of sines. And you're going to use the law of cosines for side angle side and side side side. And remember, angle angle, you cannot determine any of the lengths of the sides. So here's an example. I want to solve the triangle where B is 1, C is 3, and alpha is 80 degrees. So first thing I'm going to do is draw a triangle, because I'm a visual person and I like to see a picture. This is obviously not going to be drawn to scale, but I fill in what I know. I know angle alpha here is 80 degrees. Little a then would be opposite angle alpha. Here's angle beta with little b opposite that of 1. Here's angle gamma with 3 opposite of that. There's your C. And looking at this, you can recognize hopefully right away that this is the case of side angle side. And therefore, I must use the law of cosines because I do not have an angle and a side opposite that. So when I'm doing this with side angle side, the first thing I'm going to find is the side opposite the angle that's given. So the equation I'm going to use is this one. And in looking at that again, remember the wording of that is I have one side squared. That's the side I'm looking for, so I'm going to leave that as a squared, is equal to the sum of each of the other sides squared. So that's going to be 1 squared plus 3 squared minus twice the product of those two sides. So it's going to be minus 2 times 1 times 3. And then I have the cosine of the angle that's between those two sides, which would be angle alpha, which is given as 80 degrees. Now be careful here. You must make sure you follow the order of operations. So when I multiply all this out on the right, add things together, once I'm done I need to take the square root of both sides, and I end up with A is equal to 2.99. So I'm going to go ahead and fill that in where A is up on the triangle, 2.99. Now I still have two pieces of information I need to solve for, and that's alpha beta and alpha gamma. I'm sorry, angle beta and angle gamma. So first, I look to see how I'm going to do that. Since now I do have an angle and a side opposite, I can go ahead and use the law of sines. So I'm going to set up the proportion. The sine of 80 degrees over 2.99 is equal to the sine of gamma over 3. Multiply both sides of this equation by 3, gives me almost this. Typo, there should still be a sine of gamma here. Putting this all into the calculator will give you a decimal. Taking the inverse sine of that decimal would give you gamma is equal to 80.8 degrees. So I'm going to fill that into my triangle. Now that I have two of the angles, it's easy to find the third. I'm just going to subtract those two from 180. And my last angle ends up being 19.2. So this was a case, if you remember back to the beginning, where I gave you side, angle, side, and we ended up solving the triangle. The good news is we only had to use the law of cosines once. It's not quite as nice a formula as the law of sines, so it's good to only have to use that one once. Alright, let's look at a case of side, side, side. Okay, solving a triangle where A is 5, B is 8, and C is 9. Here's my picture. Again, this is not drawn to scale. Got angle alpha, beta, and gamma opposite A, B, and C respectively. Again, in looking at this, you can definitely see it's a side, side, side. I don't know an angle, so I cannot use the law of sines. I need to use the law of cosines. Now here's a hint. When you do these with side, side, side case, and you use the law of cosines to find an angle first, that's what you're going to find is an angle. You want to find the largest angle first. So you're going to go and look at for the opposite side, or the longest side. In this case it's 9. Go to the angle that's opposite, gamma. That is the angle that you're going to find first. Here's the reason why. If you remember back to the law of sines and the ambiguous case, it is possible to have an obtuse angle in a triangle. The law of sines, which we're going to use after we find our first angle to find our next angle, does not allow you to find obtuse angles because the inverse sign is restricted between negative pi over 2 and pi over 2, or negative 90 degrees and positive 90 degrees. So it does not allow you to find obtuse angles. However, if we use the law of cosines and I take an inverse cosine, remember the inverse cosine is restricted between 0 and pi, so I can in fact find an obtuse angle. So I'm going to look for the largest angle first. That way I don't need to worry about the ambiguous case in using the law of sines later on. So when I set this up, since I'm trying to find the angle gamma, I'm going to have the cosine of gamma over here. The side that's opposite is going to go on the far side of the equation. So when setting this up, I'm going to have one side squared, which in this case, since I'm finding gamma, would be the side opposite, which is 9 squared, is equal to the sum of the squares of the other two sides, so it's going to be 5 squared plus 8 squared, minus 2 times the product of those two sides. So that's minus 2 times 5 times 8 times the cosine of gamma, which is what I'm looking for. Again, you got to make sure you follow the order of operations. 9 squared gives you 81. 5 squared plus 8 squared is 89. Minus 2 times 5 times 8 is 80. Minus 80 times the cosine of gamma. I'm going to subtract the 89 from the other side and divide by negative 80, which gives me the cosine of gamma would equal negative 8 over negative 80, which actually would reduce to 1/10 or 0.1. Taking the inverse cosine then, I get 84.3 degrees. I did not end up with an obtuse angle here, which is fine. I definitely know that alpha and beta then will not be obtuse because I found the largest angle, and it in fact was acute to begin with. So continuing on, finding another angle. Now I have an angle and a side opposite. I can use the law of sines. So to find angle beta, I'm going to say the sine of beta over 8 is equal to the sine of 84.3 over 9. I'm going to multiply both sides by 8. This would give you a decimal on the left-hand side, and then I take the inverse sign of that decimal. Beta ends up being 62.2. And then to find alpha, again, it's easy enough now that we know two angles. Subtract those two angles from 180, and it gives you the remaining angle, which is 33.5. This is the end of the first part of the section on law of cosines.